Okay, good morning all of you. In yesterday class, in the previous class we completed HALOALKANES, HALOARENES the topic, and today I will explain some exercise questions. So one request from my side: after completion of the topic, we have to go through exercise questions. How to compulsory how to solve that exercise questions. From that only we are getting JEE bits. That's why be careful. You have to solve it, getting well and good. Otherwise, send me WhatsApp number. Send to my WhatsApp number and give the solution for you. Don't delay that one. So now from HALOALKANES, I will give some exercise questions, and next class we will see another topic. So the whole topic I will give like a one shortcut, like a charts. For alkyl halide one chart, and for aryl halide one chart I will give. Later we can see some exercise questions in this class. See, first of all, I am taking alkyl halide. I am taking. You see carefully, all of you. Alkyl halide chart I am explaining now, denoted by Rx. Okay, we have so many chemical properties we have. If you take, for example, aqueous, KOH or NaOH. What is the product we are getting? Substitutional product we are getting means we are getting ROH, we are getting those only we are calling as alcohols. Here what happening? Substitution is going on. These all things very briefly came in chemical properties, just we are drawing like a chart. Okay, same alkyl halide will be reacted with alcoholic KOH or NaOH. Elimination is going on. Under elimination we are getting which products? Alkenes we are getting. Are you clear? Yes. Now, same alkyl halide will be reacted with, for example, you see carefully, sodium cyanide or also potassium cyanide. What we are getting? Cyanides we are getting means RCN we are getting. Cyanides means what? Connection from CN to carbonate. Now you take same alkyl halide will be reacted with silver cyanide. Getting product will be reversed. Very good. We are getting isocyanides. We are getting CN only, but connection through which atom? Nitrogen atom from CN. Okay, say I will give you some other chemical properties. If you take like sodium nitrite or potassium nitrite, we are getting alkyl nitrites. We are getting alkyl nitrites means how is that one? RONO. From NO to which atom is involved in the connection? Oxygen. So we are calling them as alkyl nitrites. Okay, these are calling as isocyanides, and these are calling as cyanides. Are you clear? Yes. Same alkyl halide will be reacted with the silver nitrite. What happening? NO2 we are getting. From NO2 which is involved in the connection nitrogen, so we are calling them as nitroalkanes. Is it clear? Yes, almost all chemical properties will be coming. You see carefully. For example, same alkyl halide will be reacted with one more alkyl halide and sodium metal. It is called as a Uj reaction. Under Uj reaction, what we are getting? Alkanes we are getting. That is calling as a Uj reaction. Okay, same alkyl halide may involve in the reaction with aryl halide like chlorobenzene. In presence of which one? Sodium metal. One is alkyl halide, another one is aryl halide. What is the name of the reaction? Uj-Fittig reaction. Then we are getting which one? Alkyl benzenes we are getting. Alkyl group is attached to benzene ring. We will see some other chemical properties. You take alkyl halide will be reacted with LAH. What is the meaning of LAH? Lithium aluminum hydride. Or otherwise we can use zinc and HCl combination, or nickel palladium platinum reduction is going on. Under reduction what we are getting? Alkanes we are getting. Is it clear? Yes, the same alkyl halide may also involve in the reaction with the sodium salt of alcohol ROR-ONA. It is one of the neighbor reaction. Did you observe on what you see? Williamson's synthesis. For which one? Ethers. What is happening here? Here Na and X will be eliminating. Then what we are getting? RO, R dash, we are getting those only we are calling as ethers. Is it clear? Yes. And the last chemical property here, it will be reacted with, for example, which one? Magnesium metal. In presence of which one? Triether medium. What we are getting? Any additional product we are getting? R, Mg, X we are getting. This is only we are calling as Grignard reagent. Yes, based on this Grignard reagent, we have some other important information we have. It may react with different reagents like water or otherwise alcohol or -OH or NH3. In all these cases, I explained already in the regular classes, you see that one. But finally, we are getting product is only one, it is nothing but alkane we are getting. The alkane is especially coming from this alkyl group. This alkyl group plus H is nothing but RH. You are getting alkanes. Just I will give you one more thing. If you take alkyl halide, may involve in the reaction with ammonia. We are getting four products. What is that one? Primary amines, secondary amines, tertiary amines, and also we are getting quaternary ammonium salts. We are getting quaternary ammonium salts. We are getting ammonium salts. We are getting. You see, the whole chemical properties will be in this chart. Yes, first we have to practice step by step very slowly. Then if you remember this chart, we can do any different competitive examination. All of it here. This is the explanation or properties of which one? Alkyl halides. All of it here? Yes. Now we will see about the second part in this is nothing but aryl halides. Okay, nothing but which one? Aryl halide means benzene is there on this halogen atom is there like chlorine. Instead of chlorine, we can put bromine, iodine, whatever it is, same properties will be going on. Just you see, for this also I will give you one chart for you to see carefully. You take for example chlorobenzene. Chlorobenzene will be involving in the reaction with the one chemical, it is nothing but Cl2 in presence of anhydrous AlCl3. What happened? Substitution is going on. Electrophilic substitution from last second class we discussed this one. Okay, further substitution will be taking place at which position? Ortho position and para position. That's why we are getting which compound? Ortho dichlorobenzene, and we are getting one more is nothing but para dichlorobenzene. We are getting. Relatively, para is the most stable. And you see, same chlorobenzene will be involved in the reaction with the nitration mixture. Nitration mixture means what? It is a combination of HNO3 plus H2SO4. What may happen? Nitration will be going on. That too, we are getting two different products. We are getting orthochloronitrobenzene, and another one is para product. We are getting para-chloronitrobenzene. We are getting. Okay, same chlorobenzene will be reacted with just sulfuric acid. What we are getting? Benzene sulfuric acid we are getting. That two products we are getting. One is what? Orthochlorobenzene sulfuric acid plus we are getting para-chlorobenzene sulfuric acid we are getting. SO3H we are getting. Still we have some other very important, this one it is a chemical property of chlorobenzene is very important. Friedel-Crafts alkylation. Friedel-Crafts alkylation means it is reacted with, for example, CH3Cl in presence of anhydrous AlCl3. What we are getting? Orthochlorotoluene, para-chlorotoluene we are getting. That only write down here chlorobenzene. On this position methyl is there, and also we are getting para-chlorotoluene we are getting.
I told already this group is calling or this compound is calling as a toluene. Methyl benzene is calling as a toluene. Same chlorobenzene will be reacting with Friedel-Crafts acylation. Acylation means we have to use acetyl chloride CH3COCl and anhydrous AnCl3. Then which group is undergoing substitution? CH3CO, that is only we are calling as acetyl group or acyl group at aldo position and para position. Then we are getting two compounds, we are getting chlorobenzene as is substitution will be at aldo position and also para position. Are you clear? Yes. What is the name of this compound? All of you I told this is calling as acetophenone, argochloroacetophenone, para-chloroacetophenone. Let it be. And say this compound may involve in the reaction with the Fittig reaction. Fittig reaction is what? 2 moles of aryl halide will be reacted with sodium in presence of dry ether. What we are getting any? What we are getting? Biphenyls we are getting. I told already biphenyls means what? 2 benzene rings are connected through single bond. Those only we are calling as biphenyls. Are you clear? Same chlorobenzene will be involved in the reaction with the NaOH. That is specially calling as Dow's process. It's a very difficult, drastic conditions is required. That's why you are maintaining 623 Kelvin temperature and 300 atmospheric pressure. Then what happening then? The chlorine will be replaced with the OH. Then we are getting phenol, we are getting hydroxybenzene is calling as phenol. Over. This is the first part, this is the second part. If you got this one, we can enjoy the competitive bits and as well as the exercise questions also. Are you clear? Yes. Okay. We'll see some application, whatever is important or coming to the competitive examination. For example, given one question like this: CH3, CH2, OH will be reacted with thiamine chloride in presence of PDD, and we are getting compound A. That compound A will be reacted with alcoholic KCN, and B we are getting. What is AB is asking. Is only bits. Yes, very simple thing you have to observe. First of all, you have to see carefully. First conversion you have to see. CH3, CH2, OH is reacting with thiamine chloride in presence of pyridine. That is one of the named reaction. Do you know Dawson's reaction? Dawson's reaction. How to get it like this? This all will be possible by practicing thoroughly, understanding, practicing. That's it. Okay, you know very well. It's the most convenient method for the preparation of especially alkyl chlorides. Okay, why we use side products or gases? Let it be. These all things you learn this one. Okay, now what happening? This alkyl group will be combining with the chlorine. We are getting which one? The ethyl chloride we are getting. Or this is the compound A. This will be reacted with which one? Alcoholic KCN. Potassium cyanide in presence of carbon. You know, sodium cyanide, potassium cyanide. What you are getting? Cyanides you are getting. How? Here KCl will eliminate it. Then we are getting CH3, CH2, Cl we are getting connection through carbon, that's why it is calling as nitrile or cyanide. If you want to write a common name, ethyl cyanide. If you want to write a IUPAC name, it is nothing but how many carbons in continuity? 3 carbons, so its name is nothing but propane nitrile. Propane nitrile. All of you getting like this. So I will give you some other questions. Is a related concept to see carefully. For example, CH2 double bond CH2 will be involved in the reaction with chlorine in presence of CCl4. We are getting a compound A. This compound will be treated with the alcoholic KOH. We are getting B. What is the B is asking? This will be competitive bits. Okay, first of all, first step is the preparation of alkyl halide. Did you know how is that? You have here unsaturation. double bond or triple bond is there, then substitution or addition? Addition will be going on. Very good. Then what happening? CH2 double bond CH2 reaction with chlorine in presence of CCl4. What happening? Addition will be going on. Breaking of pi bond, one chlorine here, one chlorine here. We are getting CH2Cl single bond CH2Cl. What is the name? Vicinal gender. Vicinal it is. Why? Because the halogen atoms is lying on adjacent common atom. That's what is calling as vicinal dihalide. Okay, it will be reacted with which one? Alcoholic KOH. Alcoholic KOH means elimination or substitution of elimination. Yes, you see carefully. From here Cl, from here H. HCl will come outside. At the same time, one more. From here Cl, from here H will be coming outside. Okay, finally 2HCl will be coming outside. Write down here very clearly 2HCl. After that, which one we are getting between carbon and carbon? Triple bond is coming. Then CH triple bond CH is coming. Are you getting? Very nice. But when you are perfect in that information, you can enjoy the topic. Just I will give you one more question. You see carefully. For example, CH3, CH2, CH on it Br and here CH3. Okay, you are using which one? Alcoholic KOH you are using. What are the products? Yes, alcoholic KOH means compulsory what happening? Elimination is happening. Under elimination we have one important rule. What is the rule? Sage-F rule, or also calling as ZZ rule. What is the Sage-F or ZZ? Always hydrogen should be eliminating from the lesser number of hydrogen atom having copper atom that should be adjacent to halogen having copper atom. Means I am writing two products here. CH3. First of all, I am removing hydrogen from here. CH double bond CH and single bond CH3. One product. And one more product by elimination of hydrogen from here. CH3, CH2, CH double bond CH2. Which is the major? This is the major product according to Sage-F rule, and this is the minor product. So we are not writing minor, let it be. What is the major and what is the product here we are getting? How? So you have to see halogen will be eliminating from here, no doubt in it. With respect to this copper, this is the adjacent carbon atom. Okay, now here how many hydrogens is there? 2 hydrogen. Here how many are there? 3 hydrogen. According to Sage-F rule, from where you have to remove the hydrogen? Less than the. That's why here hydrogen, here we are getting double. So very simple. Just I will give you one more question for understanding. You see carefully like this. Cyclohexane on it CH, CH3, CH, Br and here CH. It is involving in the reaction with the alcoholic NaOH. Alcohol means no doubt elimination. Which particle? HBr elimination. Dehydrohalogenation. How? From here, no doubt Br. With respect to that one, adjacent carbon means left side one carbon is there, right side one carbon is there. Then how to go? Number of hydrogen atoms here. How many are there? 1. Here how many are there? 3. According to Sage-F rule, you have to prefer removal of hydrogen from left side number. So we are getting cyclohexane as it is. After that, from here we have to remove the hydrogen. Then carbon has CH3. We are getting a double bond here. After that, CH and CH3. This is going according to Sage-F rule or ZZ rule. All of it clear? Yes. Yes. Just I will give you some other examples. You see carefully. CH3, CH2, CH double bond CH2. You are adding hydrogen bromide and you are adding hydrogen bromide in presence of peroxide. Yes, go thoroughly through the concept. That's it. No alternative here. So you are taking unsymmetrical alkane. Yes. Why? Because left side 3 carbons is there, right side only 1 carbon is there. That's which calling as an unsymmetrical alkane. To that you are adding HBr. Are you using intermediate? No. That's why the things will be going through which rule? Markovnikov rule. What is the Markovnikov rule? It will become like H plus plus Br minus. Always negative particles should be adding at lesser number of hydrogen having double bond carbon atom. Yes, here see here, this is the double bond carbon, this is the double bond carbon having how many hydrogen? One hydrogen. Here having two hydrogen. According to Marconi rule, negative particle should be added at lesser number. So Dr will be here and H will be taken. Then what product we are getting? CH3, CH2, CH on into Br. Addition no bond breaking after that CH3. It's simple. You will get the options like this only: 1 bromobutane, 2 bromobutane, like that. Some different names you will do. 2 bromobutane is the answer. Okay, here things will be totally changed. HBr, but in presence of peroxide. Whenever you use peroxide, yes, very good. It is nothing but anti-Marconi of reverse. Negative particle will be adding at higher number and hydrogen will be at lower number. Then what we are getting is CH3, CH2, CH2, breaking of bond and Br. Very good. Are you clear? Yes. Just I will give you one more question for you. See carefully. For example, you have 1 6 number ring. Here saturation. Here CH3 will be there like this. Okay. Now to this I am adding HCl. I am adding. What is the product I am asking? No medium here. No. That's why it is going to which rule? Marconi rule. Okay. Negative particle, positive particle. Okay. Check it here. This is the double bond carbon. This is the double bond carbon. This double bond carbon has one hydrogen. This double bond carbon no hydrogen. Then negative particle will be adding at lesser number. Then what we are getting? Yes, bond breaking. After that we are getting methyl group and here Cl. That's it. That's the product. All of you getting that? No? Yes, it's a very simple thing. Just I will ask you one more question. You see carefully. Under SN1 mechanism, what is the reactivity order of alkyl halide? Tertiary alkyl halide is more than secondary, than primary, than methyl chloride or methyl halide, whatever it is. Okay, under SN2 mechanism, quite reverse. What is that one will come? Methyl halide is more reactive than which one? Than primary, than secondary, than tertiary. Why? Because SN2 mechanism is going by attacking of nucleophile from the backside. In this case, 3 small hydrogen is there, so much empty space will be there, attacking will be difficult. But under tertiary, what happening? Hydrogen atom having carbon is bonded with a bulky group, so that's why attacking will be difficult. Now, first question I am asking, you have to see carefully. This is also very important thing. So, for example, we given CH3Cl and CH3CH2Cl and CH3CH3Cl and CH3CH3Cl. What is the reactivity order of SN2 mechanism? SN2. First, we have to identify methyl chloride identity. Here, halogen attached carbon directly connected with one carbon, that's what is a primary. Halogen attached carbon connected with 2 carbon, that's what secondary. Halogen attached carbon directly connected with 3 carbon, tertiary. Under SN2, what is the reactivity order? Methyl chloride is more than primary, than secondary, than tertiary. Why? In case of this one, halogen attached carbon having bulky groups. Due to bulky groups, available empty space from backside will be less. That's why attacking of nucleophile will be difficult. That's why it will not work out. This reactive speed will be very, very less. I will ask you one more question. So, for example, I am taking an SN2 mechanism I am explaining. You have to observe very carefully. For example, CH3, CH2, or otherwise CH3Cl is there, CH3 Br is there, and CH3I is there. What is the reactivity order? Very nice concept. In all the cases, all are primary alkyl halides only. Yes or no? Primary. Why? Because halogen attached carbon will having one carbon connection or no carbon connection, they are primary. Okay, all are equal. So all are having equal speed. No. Why? Then what is happening is here which bond is there? CCl bond is there. Here which bond is there? CBr bond is there. And here which bond is there? Ci bond is there. Okay, from one compound to another compound, this carbon and halogen bond length is changing. Yes, as the bond length is changing, bonds are becoming weak. Bond bonds are becoming weak and easily easily participate in chemical action, then rate of reaction will be high. So which is more? Yes, this is less than this and than this. Why? Because their very weak bond is there. Even though all are having same nature, but the Ci bond is very weak bond because much bond length, that's why easily participate in the chemical action. Just I will give you some other reactions. SN2 order only I want. SN2 order. For example, I given CH3, CH2, 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 Cl is there. Otherwise, you can take one more CH2. 5 compounds is nothing but chloropentane. I am taking one more compound is nothing but CH3, CH, CH3, CH2, CH2, Cl. I am taking one more compound CH3, CH3, here Cl, and here how many carbons? 5 carbons. No. Sorry, you have to get one more. It is nothing. Yes, here okay, but here we are getting a CH2Cl. Here we are taking CH3. Just check it very carefully. I want to find out the SN2 order. It is a which type of alkyl halide? Primary. It is also primary. It is also primary. Very nice switch. Why? Because halogen attached carbon directly connected with only one carbon. So all are having same kind. But even though the SN2 reaction speed will be different. Why? And where more? Totally observe one thing, SN2 mechanism is going through attacking of nucleophile from backside. Observe the concept. In this halogen having carbon, only one alkyl chain is there, but 2 hydrogen will be there. Then available empty space will be more. Yes, that's why this compound is more reaction speed. Okay, here also 2 hydrogen is there, but 1 branch is there. Due to 1 branch, what happening? More space is occupied. Why? Because as the branches is increasing, the